Val, thanks for taking some time at the end of a busy day to chat with us. But we really wanted the perspective of talking with a veteran teacher who problem solved, did the problem solving and communication process with her fourth graders, and it wasn't happening in the sending grades. And over the last 2 years, in this particular school, we've introduced problem solving in kindergarten in first and second and third grade. And now you are receiving the children that have had that training. And we just wanted your perspective. It's pretty much like action research. It's like, we know what you're going to say, as opposed to no training versus training. But we just wanted to get your perspective on the differences you're seeing when everyone on staff is on board.
Okay, when no one else in the school was doing this, the kids would come in, transfer in from third grade. They had no idea at all what a problem was, how to read it, how to separate math pieces out of it, how to get rid of just the extra language. They didn't know anything about math representation, connections, nothing. Vocabulary was non-existent. And I had to start right from the get-go and work the whole year trying to get them up to speed. And there's no way that I could enhance the vocabulary or the connections. And once you started in and brought that knowledge into the teachers from K to 3, then when the kids came in 2 years ago, I initially had my whole program like I used to, and it was like, blew me right out of the water. I go, this is too simple. And the kids already came in knowing what a table is. They already came in knowing what a diagram is. They came in with some math language, with some connections. They had the I need and I will statements down. And so, I mean, you could just take them and excel with them with the connections and enhance the math language. And the teachers, I noticed too, are more willing to discuss with you, like at teachers' meetings or when we do action planning, what they are seeing and how we can support them. And I see a lot of teachers coming to me now feeling more comfortable because they now know what questions to ask me so I can help them out.
So you're finding the portfolio to be a formative assessment while you walk around the room
Yes.
and watch your kids?
Mhm.
And because you're not doing a lot of catch-up, you're able to use it more effectively. Can you talk a little bit about how you use it as a formative assessment? Like when you walk around the room and you see a child having difficulty with computation, what does that trigger in your mind? Or how do you use that information the next day?
Basically, it shows me where kids have their holes or what they haven't understood, and that way I can break it down and help them out with differentiation, where this kid's need a little bit more, maybe on multiplication or factors or multiples, or this child needs a little bit more. Like for today, I noticed some needed more practice on how to break down trapezoids to hexagons and show the fractional part and how just building the whole, to get them to build the whole and then break it into pieces and take that one piece, take the piece away. You know, just and see where I need to go, maybe because we have a math person, where a coordinator person, where they come and pull kids out, or she comes and works in my classroom 3 days a week, so she'll work on them. And in the afternoons, 3 days a week, I also have a para that will take children, and I can then break the children and say, okay, you need to go work with this, doing this. And this is, it just enhances the kids. And I was doing some of the SNAP assessment with 3 of them, and I had kids counting forward, counting backwards, on decade, off decade, and they couldn't have done that. There's 3 of them that could not have done that this year without me assessing that and seeing that in some of this portfolio work.
So you're finding, even though the portfolio process is really assessing problem solving and communication, you're still finding it a strong diagnostic tool for computational fluency.
Absolutely, and it takes the kids outside the box, and it makes better connections to what they did last year. Brianna today with halves and doubling, she made that connection because we've been doing that with multiplication, and it just makes a better connection, and it makes a better math person.
Because you're not doing this massive catch-up, do you find the disposition of your kids mathematically happier? Do you find them, like when you do problem solving, they're engaged and more excited about it instead of shutting down because you have to stop and teach them this is how you make a table?
Yes,
Are
yeah,
you
they're-
finding a real difference this year and last year?
Absolutely.
Yeah.
They're ready to go. And then I can enhance it by talking about how can you connect this with multiplication or fractions or multiples or other geometry aspects or concepts or fractions. It just depends on what we're working on. So it just brings a deeper understanding of math.
One of the biggest complaints we hear from teachers around the country is, I have to do my program and now I have to do this, even though it's part of their state standards. How can you explain to a beginning person to this process how problem solving is embedded in your program, how you embed it? You know, so they don't see it as two separate jobs.
When I'm working on a math concept, and it just leads into, I have tons and tons of pieces, and it just leads, just naturally, a great flow right into a problem-solving piece. And sometimes I will use that problem-solving piece as a check or as a summative assessment for that particular GE or standard. Just depends.
And
'Cause
have you skipped parts of your program, pages in your program, because the problem-solving task has the same information on it, but it's a
Yeah.
little richer?
Yes.
So it's not repetitive then?
No, I always go to the problem solving because the kids have to go so much deeper with actually writing it, solving it, connecting it, also verifying it. And it's a much better way than much better way. And if they were going to take portfolios out tomorrow, I would continue teaching them on, because 15, 16, I don't know how many years ago I started, it was a whole new concept for me. It's like, oh my goodness. And I truly, truly believe in it. They are much better problem solvers and math thinkers by doing problem solving.
How would you address the issue we hear a lot, kids can't self-assess?
Oh, yes, they can. Oh, yes, they can. Looking at just at the class today, I had one little girl that used triangles instead of rhombuses, and they go, oh, that's why I didn't have the right total, because I didn't. Mirror image is correct, but I didn't use the right shape, so my total amount is off. That's self-assessing. That's just a little bit. Going on with building the shapes to find fractional parts and finding the equivalent fractions. What's another way of looking at it? And just advancing the kids that are ready to go into equivalent fractions instead of 3/6, 1/2. And you can tell where the kids are ready to go. So you not only do you help the children that are having a harder time, but you can push the kids that are ready to go on further.
And you always get that wow moment.
Yeah.
When I was walking around your class and everyone was saying a rhombus is 1/2, this is 1/6. One of the students in your class did everything in sixes. And she said, well, the trapezoid is 3/6. And I said, well, how can that be right? Because 3/6 is 1/2.
Right.
And there was an aha moment. One last question for you. You've been an incredibly gifted math teacher for many, many years. And how do you explain to teachers new to the process the difference between a word problem and problem solving? Because so many teachers think that problem solving is, I bought 4 apples and 3 bananas, how many pieces of fruit did I buy? How do you approach that with educators that say, I am problem solving, it's those 15 problems at the end of the book?
A word problem is a quick answer. Problem solving is a concept where you have to go through many concepts to get to the final answer. And there's many ways of, when you solve the answer, you have to verify it. So there might be another approach to doing that. For connections, you need to go beyond the immediate answer. You know, how can you connect it to something else? What have you done mathematically? What can you do? Compare and contrast, you know? You don't do that in word problems. Solution, is it completely correct? The math representation, there's all kinds of ways that kids can choose to solve it, you know, and they have that whole plethora of information that they can decide how they want to show it. And then, of course, your language, you can always beef that up and just get them to thinking about what's something besides pluses and minuses, you know, just improving math language and what are other things that you can do. So this is a word problem is short and immediate. And a problem solving sometimes may take you 2 or 3 days to do. You know, and you can build on problem solving where it gets very basic and you can get more elaborated over time with the same kind of concept.
So one is strictly computing.
Yes.
And one is really exploring and reflecting and
Right.
computing.
Right.
Yeah.
And it just brings the kids beyond of what a simple answer is. You know, 2 + 2 is 4, but what makes it 4? And that's what problem solving does. It just makes them better thinkers, and that makes them better lifelong learners.
Your students, their parents, and the teachers that you work with are just so lucky to have you. You are just amazing. Thanks, Val.
Thank you.